Hi everyone, today we will be doing gel electrophoresis. The material or ingredient needed is a razor blade, stainless steel wire, wooden craft sticks, agar-agar powder, masking tape, 5 pieces of 9-volt battery, and a plastic container. Hi everyone! After waiting for 15 to 20 minutes, let's look at the result. Ta-da! As you can see over here, all the colored dye had traveled from its initial position in the well. For your information, the holes here are called wells. The colored dye will travel from positive electrode to negative electrode respectively. The first color inserted in the well from the top is purple, followed by green, yellow, blue, and red. Then, after 15 minutes, the purple color has separated into blue and red, while green color has separated into yellow, red, and blue. Since yellow, blue, and red color is basic color, it will only be separated into one color, which is the same as it is before it undergoes separation.
Now moving on to discussion. The first discussion is the distance traveled by same dye is equal because their movement is governed by the same physical and chemical properties under electrophoretic conditions. The chemical and physical properties are size, which is molecular weight, and charge to mass ratio. For the size, two molecules of the same size encounter the same resistance as they move throughout the gel matrix. This causes them to travel in the same distance. Next is the charge to mass ratio. The electric force acting on them is proportional to size, causing similar sized DNA fragments to migrate equally. Secondly, is the distance traveled by a dye is affected by the size of molecule. Smaller molecules travel faster and further. Larger molecules travel slower. Factors that influence the distance traveled are gel matrix and also friction. For the gel matrix, it's because the gel is like a sieve with tiny pores. Smaller molecules can pass through the pores easily, which contribute to their fast movements, whereas for larger molecules, they face greater resistance as they try to navigate through the gel, slowing down their movement. Moving on to friction. When molecules migrate through gel, they also experience friction. Smaller molecules encounter less friction, allowing them to move faster, whereas larger molecules experience more friction, slowing down their movement.
So, how can we relate this experiment to DNA fingerprint? So, after the DNA has been digested with one or more restriction enzymes, it is separated by size using gel electrophoresis. DNA fingerprint can be used to identify suspects when a crime has been committed. In this case, the bands in the DNA fingerprint of the culprit will be an exact match to the bands in the DNA fingerprint made from DNA that has been taken from the crime scene. So, in this case, we will insert the DNA collected from the crime scene into one of the wells and the DNA of the suspect into another wells. If he or she is the one who committed the crime, the DNA of the both sample would be an exact same. Moving on, DNA fingerprint can also be used to determine paternity. In the case of paternity, the DNA of a children would exactly match the DNA of either of the two parents. In fact, you would expect that only about 50% of the bands in a child would match either parents. This is because the meiosis generates haploid gametes that each contain one copy of each chromosome. So, to determine the parents of our children, we will insert the DNA of the children, the DNA of the mother of the children, and a few suspected fathers of the children. The DNA of the children will be a combination of the DNA of the mother and the DNA of the father. Therefore, the children cannot have DNA that doesn't match the DNA of one parent or the other.
That's all from us. Thanks for watching.
Bye!
Bye.